Hello everyone, welcome to the episode 51 of SoLeadSaturday. The guest we have today, Dr. Ganapathi Pulipaka. He is a chief AI HPC scientist with over 20 plus years of SAP experience in project management of application development, technology integration of business systems design and architecture. 9 plus years of experience in deep learning, machine learning, data science, PyTorch, Python, TensorFlow, and R. He has extensive experience in business systems design management consulting, project planning, and management in successfully delivering those by collaborative program results by partnering with client for SAP and artificial intelligence with 31 projects. Wow, this is amazing. He has so many years of work experience. So it would be going to be a very insightful talk. So I'll just welcome him and welcome Dr. Ganpati Puibaka. Very happy to have you on the show and really appreciate all your time and consideration.
Sounds great. Yeah. Thanks for inviting me and having on your podcast.
Yeah, thank you so much. Pleasure is all mine. So moving towards our first section, which is common to everybody about the passion and the interest. So how did you find your interest in the data science field, big data and AI? What steps did you take to pursue that passion?
So I would like to begin, the grassroots of where it all began. So actually, when I was 16 years old, that was the first time when I actually started assembling a CPU, a computer on my own.
Mm-hmm.
So I just wanted to see if I can assemble on my own, like without going to shop or anything. Then I got all of the components and actually built and assembled a computer.
Mm-hmm.
And when I did that, so since now I have the computer, so I started working on programming languages like C, C++, Visual C++, parallelly at the same time going to school and also pursuing all my programming language efforts at the time. And so as I started doing that, I found some astounding opportunities.
Mm-hmm.
And at that age, actually, I saw there was a requirement at Air Force Academy who was actually looking for implementation of C++ programming language for their air traffic controlling.
Mm-hmm.
So I went in personally and I spoke to them and they said they were happy for me to do that project for meteorological department in terms of understanding based on different weather conditions, they can decide whether a plane takes off or which runway is going to land on, all of that stuff. So I did the project and I implemented for the Air Force Academy, and they have been using it for many years and decades. And after that, there is another company, which is electricity board actually. And so they wanted to implement a project to measure the consumption of utility and the meter reading on the energy and stuff like that. So I implemented all the statistical methods for them, quantitative and qualitative methods, and I've shown based on the meter reading how the customer can actually measure the utilization and actually also compare the neighborhood where people are how they are consuming versus how this person is consuming, applying different types of statistical methods. And so actually the electricity board is still using the product as of today. And this was my first project. So then I really got interested into the data side of it because there's a lot of stuff that can be accomplished because majority of the stuff, everything is all about data. So that's when I started working on a lot of projects, and I started implementing a lot of projects for various businesses as we're mentioning about the business industry. So I work for chemicals industry. I work for aerospace and utility, energy, and a number of life sciences, healthcare, including entertainment, and one of the largest entertainment clients in Los Angeles I work with. So there are lots of data, and there are actually terabyte data on the business warehousing side for performing the analytics. So that was the largest project I worked on the side of the business warehousing. And then I started running a lot of business analytics and getting the outputs and also applying the algorithms. And I implement around 32 projects as of today. Sometimes my profile may not be up to date. I don't keep updating all the time. So, ever since I worked on all of these projects, then almost a decade ago, I also started into the data analytics side of it. And I have a degree and a specialization of running on the business analytics and the data analytics. For example, like Tableau or Quicksilver, and also Microsoft Power BI, and a number of BI analytics tools that I started picking up when I joined the degree with California University at Irvine. That was almost a decade ago, and then I implemented all of these projects and all of these tools, every possible analytics tools out there. And then again, there was also some machine learning and statistics I picked up from the curriculum. And later I pursued a Doctor of Computer Science program where I was specializing more on the big data and machine learning analytics side of it. And then I did a postdoc with the Colorado Technical University where I actually implemented a lot of projects, and especially on the high performance computing. And I have a specialization in high performance computing with deep learning. My dissertation is on that entire topic. And I don't know whether I'm still debating if I should publish it as a book or I should publish it as a research paper, but that's a large scale dissertation I have written. And a lot of research publications already have come forward to accept it. For example, like ACM, which is a popular research publication, and IEEE, and Springer Nature Link also contacted me. I haven't published yet. I still don't know if I'm going to publish it as a book or I'm going to publish it as a paper. But at the same time, working on a couple of books right now, and the books are, the first book is about more on the mathematics of the machine learning, like how we can implement linear algebra or calculus applications, and how leveraging the Python and or PyTorch or TensorFlow, how can we go and implement these projects? And that's what I'm currently, working on a book. And there's another book also I'm working for another popular publisher, which is actually on the reinforcement learning algorithms. And so that's about advanced systems of robotics and how do we implement reinforcement learning. And that's mainly on PyTorch. Already I've completed a few chapters. I completed a few chapters in the first book, but I still have to complete all chapters and refine it and fine tune it before I can publish it. So those are my projects in the pipeline.
Wow, so you are so busy actually, the way I am understanding it. So you are trying to get the knowledge from everywhere, and then you are sharing it as well through your books or through your work and the projects. So thank you so much for sharing.
I've written around 400 research papers back in the past decade. And so these papers cover a wide range of topics, and from IoT, and then you have IIoT, and then you have React.js, you have several web frameworks, and a lot of applications covering a wide range of topics, including machine learning algorithm, deep learning algorithm, natural language processing, and also bio-inspired machine learning algorithms, more on the genetic algorithms and all of that stuff, and robotics, and so it covers a wide range of topics. So considering that the postdoc was the toughest period, they have to be completely coming up with innovative topics. Every research paper I have to write cannot be the same as the other paper, because and especially also the most important thing is plagiarism, because it's important. A lot of people publish a lot of articles these days, and just because I take some of the articles and I paste them into some of the plagiarism tools, like Turnitin. There's a plagiarism academic tool, so you can find out. So you paste some of this article over there, it's going to show especially tags the content, like they just copied and pasted, or even they reworded it by copying it from particular research paper or a newspaper article or anywhere. It is going to show that up. So that's the tough thing about postdoc is like you can't have even a single word that is copied from somewhere. It has to be completely original and completely authentic, and that's the only way the paper is going to be even accepted by the university.
Yeah. Thank you so much. Actually, the way you are talking, it shows your passion towards the field. So thank you so much for being my guest as well. Moving towards our next question, next section is more about questions from the audience. So I have shortlisted a couple of questions for you. The first question is, what are the major challenges when it comes to big data handling at organization level, and what would be good big data strategy?
So it all depends on how much data the company wants to handle, because primarily, the company, if they have large scale data, then they are looking at several frameworks like, the conventionally, most of the people leverage Apache Hadoop, which is most popular tool where it's leveraged for the storage. People can store large volumes of data on Apache Hadoop, and then they can process it by applying different data mining algorithms and extract the insights from that particular data. And some of the other companies, like as I was talking about utilities and energy companies, they need a lot of data in real time, and they will need streaming engines that basically can capture the data from different places and then get that data into the data warehousing, and then sometimes they have some IoT sensors from the industrial manufacturing plants, because I work for a client like that process all of this data from the IoT sensors and process into Apache Hadoop through Apache Spark or Apache Flink. A number of streaming engines are available out there. Even MapR has its own data platform. Again, when we are getting the data, right? So it's not always like we need to extract the same data over and over again. We need to be able to go for that change capture, because there is a data that came yesterday, and again, if you are retrieving the data, we don't want to retrieve the same data again because it's going to double up the whole volume. So we need to find the change between what has been transmitted yesterday versus what is transmitted this morning. Let's say meter reading units from electricity or somewhere we are getting the data sources from. So that there is a data change capture tool called Debezium that actually captures the data and then puts it into any of these data storage units. And there's also several other techniques to do this, because instead of putting in Apache Hadoop, which may not be faster because it's a disk-based system, so we can go to some of the in-memory computing platforms. So for example, SAP has HANA, which is a high-performance appliance analytical tool that processes data. It has set a Guinness Book of World Records for handling largest big data analytics, where it has processed like, we're talking about like petabytes of data, not like something like terabytes of data. And again, if you're, you have several other tools for that purpose. Like, for example, you have Hazelcast, and you also have GridGain, which is a in-memory computing platform. So all of these platforms, what they do is they keep all of the data on the memory instead of keeping it on the disk. Because for getting the data from the disk, you have to make a round robin trip, and then you have to keep going. You have a lot of SQL engines, you have no SQL engines to extract the data from these data sources and get the data into your data warehousing location. So it's going to be very complicated extracting all of this data, with any technique. So it all depends on how the company wants to do it. Whether they want to go for an in-memory computing platform, or they want to go for any Apache Hadoop or disk-based tools, or they can also add some streaming engines if they get in the data in real time, or it's something like the batch the data. It all depends on their process. Like, people may have e-commerce applications running on the web, and then they need to process and the website crashes because, it all depends on the architecture that needs to be designed is totally dependent on the business design and the business requirement. So that's when we can basically bring in all of these necessary tools and come up with a big data strategy that works. Because not all the times one size doesn't fit all, because you take the approach that you implement a big data strategy for one company and then you go for implementing it for another company. All of this may not be the same, because you need to scale the company, understand the scalability of the servers, infrastructure, how much data they need in terms of processing it, and then we need to come up with a big data strategy for that.
Thank you so much. And next question is around types of data actually. So what is metadata, master data, and transaction data?
So the metadata is basically the data surrounding how do we define the attributes of this data, right? So for example, like somebody is designing SQL design for multiple tables or views, or what they need to do is first they need to define the metadata. The metadata is primarily the way how just think about the universe. So everything we see is metadata, versus like the actual data is like all of these galaxies that are populated into the universe, and in a specific time and space, like in space-time continuum. Similarly, when we are creating a table, we need to know what type of data are we collecting. Are we collecting a vendor information or vendor address or something? So what does it need in terms of defining the attributes of the data? There's going to be a character field, there's going to be a string field, there's going to be a floating point, there's going to be integer byte, all of that we can define in the table, and then that becomes the metadata. And then when we start actually implementing it, we need to have the master data. The master data is kind of like, the linchpin that holds the data together, where we need it mandatorily to perform any business transaction. Like, as I mentioned, we're talking about a vendor, we're talking about a customer, we're talking about a material product. This is all master data. And then there's always a lot of master data governance that's required, because we can't just, to put some data and then just deliver it, because it needs to be governed, and it needs to be, in a way that helps actually to get the master data ready for the business organization. And then we also have something called transaction data. Again, transaction data is where you have maximum number of transactions generated on a specific day. For example, like if you have Black Friday, then you can expect, almost the transactions generated throughout the year can happen in a single day on a Black Friday. So that's what is a transactional data. So I was talking about the entertainment company. So they manufacture this Blu-ray discs, and they manufacture the DVDs and stuff like that. So when they sell it on, on a particular Black Friday, it just goes crazy, like millions of them, the website crashes, and all of that stuff can happen in a single hour. And you need to have scalability. So when we are building the cloud computing platforms, we need to scale with Amazon to see how much data we can accommodate. It's more better than to be preventive rather than being reactive, because when customers going to the website and crashing the whole thing, and then put a some notice, oh no, we are all down, and we're going to be back in an hour after maintenance or something. That's not really good, because we need to scale and understand, and we can spin up any disks on the clusters of cloud computing if we need to scale it up more. And that's what Amazon does, because it's stateful computing. It doesn't have any servers for us. Like, we're not storing the data physically on any servers. It's everything in the cloud. And, so we can just process all of the data, most efficiently. So that's how the transactional data needs to be designed. When they want to build a transaction, they need to decide, are they going to put it in a cloud computing platform, or are they going to just put it on some sort of a database? Or like, if it's a healthcare industry, they have a lot of complaints in terms of like, electronic data records. They need to keep the compliance, and they can just, put the data somewhere. Like, people are going to, there's a HIPAA compliance, is a very specific regulation of healthcare industry. So the electronic data records of the patients are being protected, so that they're not being shared with others and nobody else can access. So we need to put some security regulations for such type of electronic data records, so that the healthcare data of a person remains more safer than putting it out there. So there's a lot of cybersecurity rules provided by HIPAA. which are basically the government rules for HIPAA. So transactional data gets very tricky because we need to understand what type of transactional data we're dealing with and how we can handle that so that we can process it for the right industry at the right time with the right scale.
Yeah. Thank you so much for sharing, and I'm sure that the audience will be benefited with the answers. So thank you so much. Moving towards our next section is a more or like a fun segment. So I'm going to give you 3 words, and you have to tell what comes to your mind immediately. So are you ready?
Okay, yes.
Yeah. So the first word is passion.
When it comes to passion, machine learning is my passion, especially dealing with high performance computing. And as I mentioned, also the in-memory computing, it can be applied to AI, not only for the big data and Apache Hadoop and Apache Flink and Apache Spark. So basically you can apply this to there's a separate hardware like neuromorphic hardware, the neuromorphic hardware actually started all the way with building the transistors, memristors, capacitors, and resistors, and it moved all the way so that the data resides in the neuromorphic hardware, and then there is a specific neural network that are defined for it called spiking neural network. So the spiking neural networks is exactly where we can scale the data with neuromorphic hardware. So that's my passion because I'm also writing a lot about it, how we can implement it for supercomputing and how we can implement for nuclear fusion and how we can implement for a plasma turbulence because the energy that we have in the world is very limited because we experience a lot of outages where we don't get a specific electricity when people need it. So the reason that's why people actually started moving towards nuclear fusion. Is it something that humans can harvest and actually can extract the energy from the way the sun produces the helium and then builds the nuclear fusion process so that it produces so much of energy? So that can we rebuild that concept and can we bring that to the Earth where we can produce unlimited energy with nuclear fusion? So a lot of supercomputing companies like Lawrence Livermore Laboratories, Sandia National Laboratories, a number of national research laboratories are implementing this nuclear fusion projects where they want to produce this because, especially on the heat generated, it's just like almost extreme temperature reaches almost like the center of the sun, and you can't just have it. So they put something like some type of fixture so that holds up the heat so that it won't break down and get into the labs. And there's also like a bomb simulation that people have started as soon as they started getting the deep neural networks. Because earlier, what used to happen was, before the invention of the deep neural networks, people used to, bombard the islands and just annihilate them and just to see and understand how a nuclear bomb explodes. So, and still some of the nations do that. But coming to the supercomputers, ever since we got the supercomputers, so we can actually now do a bomb simulation in a supercomputer. So we know the projectile of how the trajectory of all of these explosions or simulations of particle physics are occurring, so that we can measure it and we can understand without having to actually bombard and annihilate the islands. So this is all possible to supercomputing and high performance computing, coupled with in-memory computing and neuromorphic hardware, as well as spiking neural networks. So I believe that's where my passion is, and you will hear more about it in my upcoming books, how to implement these type of applications.
Wow. So I can see clearly your passion actually, because you're not, you're like unstoppable when it comes to your passion. So thank you so much. The second word is for you is moreover like research.
Yeah, research again, it's a very tough because especially researching is something like, that's something that's never produced. It's completely unpublished manuscript that people have to come up with because they need to understand and come with original ideas that are not being produced by any other person or researcher, whether academic or practical in a project throughout the world. So I'm very interested in the research and I read, lots and lots of research papers. I mean, it's not that I only write. I also read a lot of these papers to understand how the researchers have been moving towards the next generation of AI applications and what are the type of applications are they implementing? Is it supervised learning? Is it unsupervised or semi-supervised learning? Are they implementing reinforcement learning? What type of machine learning algorithms are they implementing? And how is it being more efficient? Because again, they apply a lot of hyperparameter optimization to tune the neural network so that, if they're applying back propagation or they're applying the forward propagation, how do we get all of these weights updated? How do we activate the neural network functions? Especially when we start applying, there are a lot of Adam and, so different types of optimizers are available. So we can implement these optimizers and measure, benchmark each of them and understand, how, that's when we can publish a research saying, okay, so we actually have run this algorithm on multiple hardware systems and we have run it on multiple optimizers of neural networks and we can compare and see what's the best to go with. So that's very interesting side of research, yeah.
Yeah, thank you so much. And the next word for you is academic experience.
Yeah, I believe the academic experience is very important because a lot of people, they implement the projects implementing the projects in the real world is not so different from what academic researchers come up with their own thoughts and ideas, how they implement it, because sometimes it's very surprising that practical people, machine learning researchers implementing the projects, actually when they compare and check with the projects that have been implemented by academicians. So it's not, they come up with several concepts because the academics also, you have so much of research, that you can implement and then you can come up with, for example, MIT research performs so much of research on it. And recently they crowdsourced a reinforcement learning algorithm for measuring the traffic and how do we optimize the traffic with reinforcement learning. So we built this in a JavaScript front end, and they optimize the traffic roads, like, on a multi-lane freeway, there are cars that are going, how do we get around? Because there's still space, and most of the time we see traffic congestion. So, I think I believe it's the best is to open source and outsource and crowdsource this type of project so that everybody can participate in it, because 24,000 people have participated on this, and it has produced 96.6 million hyperparameters and 512 years of simulation. It has created to know how the traffic is going to look like. A single researcher possibly could not create a 512 years of reinforcement learning traffic simulation. So that's why you need all of the people to collaborate together and, come and work as a team and then, understand the different types of algorithms that they can implement. So I believe that this is only possible, when people are more connected toward academics, because the people on the practical projects are scattered and they don't have a lot of network. I mean, they do have some networks on LinkedIn, but that is more on different, application framework. But academic people on the academic side, they actually connect on the research side, so they contribute towards these projects. And the project I was talking about was completely built by the, machine learning researchers on the academic side, and not like on the people working on the project.
Yeah, thank you so much for sharing the importance of academic research projects as well. So thank you. And moving towards our next question, next section is about career and work. So you are an author of books which includes The Future of Data Science and Parallel Computing, Big Data Appliances for In-Memory Computing, a real-world research guide for corporations to tame and wrangle their data. Big Data Appliances for In-Memory Computing, a real-world research guide for corporations to tame and wrangle their data. Would you like to share more about it? And you are planning to have the free giveaway also, so that would be great actually if you give some insights. You already gave a couple of, but that would be great to just summarize.
And so basically this book is about all the big data strategies, and not only the big data strategies the corporations can adopt, but also there are a number of projects from 1950s onwards, there are like 60 projects that have been implemented. And, the book takes, all of these projects and it takes a deep dive. Like we are like looking at Human Genome Project, for example. How do they gather the data? What are the tools that leverage for this Human Genome Project? Because back in the day, there was no in-memory computing. For the Human Genome Project, it took literally like almost more than a decade to understand and decode the genome, right? Because they did not understand how the genome works and how and what is it comprised of, and how people can understand and analyze different diseases and what data tells about it. Clinical trials, various aspects of life sciences industry. And if you're going for again aerospace, there are a lot of preventive maintenance and industrial machine learning and big data tools that can be implemented. So it also provides those projects insights, how people have implemented on the aerospace side, like we're talking about like Lockheed Martin projects from aerospace. We're talking about US Air Force. You can find all of those projects, how they have implemented on all of these projects, and how they can actually be leveraged for any other airline industries, because it's very important for the airlines to have this type of geospatial applications, that they know that when a plane crashes, for example, they don't want to discover that through decoding some box that they find, and then they're gonna discover what's happening with this crash. So it's something that we can prevent. So it talks about implementing all those technologies and software, and implemented for a actual aerospace customer, a project I implemented it where it's about putting all these sensors, industrial sensors. There's another company that has been successfully implementing on Airbus, IBM. So they put like 10,000 sensors on the wings of the planes and the turbo engines, actually. So they get the readings of the mirroring of all of the atmospheric conditions. So instead of basically, deciding, for example, the ground station has some kind of a weather that tells them, okay, you're going to get a storm, and then so they would understand. But sometimes they can't tell that there is a storm upcoming, because some of the catastrophes that people encounter, they don't know that they're getting into a storm because the satellite doesn't tell them, so they can't tell them. But these sensors, they actually pick up this data reading directly on the fly in real time. They can capture the data and get that into the sensors, and they know that. And then also it proposes a detouring plan. Okay, instead of getting into the storm, you can actually detour and get around it, and you can not get into the storm at all. So, and then avoid the turbulence altogether. So these type of projects are something where you can find in those in the book. And also we're talking about brain initiative. Again, there's a lot of research that has been conducted on the brain from 1950s. There's a lot of momentum people have understood. So like people have known that there are 87 billion neurons in the human brain. So how do 87 billion neurons operate, and how do they communicate the neural pathways, and how they transmit the data to synapses, and how the synapses get the inputs and then process and then produce the output for a person to make a decision. Because this is all about a predictive analytics. So how the brain processes and produce the output of a predictive analytics is the same way human wants a machine to operate. So there's a brain project initiative, especially on the data side of it, machine learning, that has been funded with $1 billion. They want to decode the brain, understand how the neural pathways work, and how do they communicate, and how can we actually replicate that in the machines. So there's a University of UK, and they actually have implemented a supercomputing project called Spinnaker, and that's built with ARM processors with 580,000 cores of ARM. And so again, we're talking about the brain. The brain has around 20 volts of electricity. That's it. And that's all it takes to process 87 billion neurons to get the output of all of the decisions you make. And it's so simultaneous and it's so synchronous. So the University of UK, so basically on the 580,000 course of processing they're doing, they want to simulate all of the brain. So they're working with this brain project. And so they want to know how do we actually get this, decode the brain understanding. So they ran this on the ARM supercomputer they built just for the purposes of brain. So these are the type of projects you can find, and in my past book, and also you can find in the upcoming books more projects I'm talking about, like plasma turbulence, nuclear fission, national nuclear weapons project. Like you need to have special type of trucks. The truck that's going next to your neighborhood could be carrying a lot of nuclear weapons. You just see a huge truck going in there, but how do we contain all those nuclear weapons safely so that it's not going to have problems? So that's when machine learning is applied in the supercomputing, and you come up with a strategy of how to transport these nuclear weapons from one place to another for that. So all of the projects will be found in the upcoming book, and the other projects I spoke about are already in my existing book with all the big data tools, how to implement it, how do we run the analytics and get the tools and dashboard, and analyze the genomic side of it, bioinformatics. We're talking about quantum chemistry, talking about quantum physics, or we're talking about CERN project with particle physics, where we always know there's a standard physics model that provides what are the particles, like we're talking about electrons, neutrons, or we're talking about different types of gluons, mesonons, but again, there is another particle called boson, which is actually, something they think it exists, but it was always kept as a question mark on the standard physics model. The CERN, which is in Geneva, has conducted this project on the particle physics. They want to accelerate and collide, particles with particles, like billions of particles, to see if there is a way they can find this boson. So ultimately, they found this particle, repetitively at a particular scale, and then so that's when they mark this boson in the standard physics model. So those are the type of projects on the particle physics side that are very exciting, and some of the like spacecraft that were launched on the Mars were run through the reinforcement. I know NASA has launched a lot of spacecraft onto Mars, as you know, right? And it all works through reinforcement learning.
Okay, so moving towards our next question is another area of your interest, which is IoT as well. So would you like to share more insights around AI and IoT? IoT is Internet of Things, and how AI-enabled IoT creates intelligent machines.
So IoT is a very powerful concept, as I was talking about. It's very, very good in the aerospace industry. Again, I'll give you a project of IoT. I'll talk about a couple of projects, a project that I worked and a project that actually was a prototype. So basically, every infrastructure, right, in the world goes through aging, because all of the infrastructure gets deteriorated over a period of time, and it can't, withhold the infrastructure. For example, we're talking about a bridge, right? So there was a recent bridge in Minnesota that actually, while number of cars were traveling on it, it just collapsed. The whole bridge collapsed, and I think 13 people died on it. The cars, I don't know the actual people, but those were a number of cars. So when this happened, so what was the reason? Because they did not know that the bridge cannot, hold, and basically the surface of the bridge is deteriorating because of number of vehicles going through it. And it's, they've been traveling on the bridge for so many years and decades, and almost like 1900. So how do we know that this bridge is going to collapse, right? So the way we know that this bridge is going to collapse is basically, there was an invention that there's a company that invented. This is in Minnesota. So this company has invented a sensor which is only like $20. And so all people have to do is they just put that sensor under the bridge. And it's so, lightweight chip, and you can just put it on the bridge, and they put like number of these sensors on the bridge. And when they put these sensors on the bridge, what it does is it actually measures the structural integrity of the bridge. So, how was it, it was before versus how it is now. So they can measure up, and, if there is some a change that is occurring in it, you can actually start transmitting some signals. So people know that, okay, now the bridge is, kind of is getting into some sort of problem. So they can take care of the bridge, and, they can actually, come with some preventative measures. So there are a lot of techniques to rebuild the bridge, or, to structure it in a way it's not going to collapse. So again, the cost is so less because it doesn't require any batteries. It doesn't require any other type of, fuel or anything like that. It just operates on the light. So it just gets the light, just the sunlight, and it just stores it, and it runs even in the night with the same light. And then it starts again. It's connected to a cloud computing platform, transmits all of the data in real time. And, people go into that, and they actually can, analyze to see how the structural integrity is still good. So, but again, this is not implemented at a national scale, but I think this is something very recommendable, because I would say a lot of lives, because people don't know when we're going a bridge is going to collapse or not. It's not a big. So this is a very good IoT project that has been implemented by a company. And the other project I'm talking about is something that I implemented again for an aerospace customer. And this project has been prototyped on Azure cloud computing platform. So again, if you're in a plane, there's a lot of panels that are there in the plane. So you have floor panels, and you have door panels, and you have panels on the ceiling. So this is how, the airplane holds the structural integrity of the plane, because you can't put very heavy components, obviously, because, the plane is supposed to carry so many passengers. So there are restrictions in terms of the weight, how much it can carry. So this project is actually to, put the IoT sensors in the panels so that they measure the structural integrity of the plane. So these panels, again, it's very hard to know when people have to do preventive maintenance, because they sometimes run for a year, sometimes they run for a couple of years. So you don't know how long people need these particular panels to be there, and how long it needs to be there. So in order for people to know that, the way people usually do conventionally is people go there, they check, okay, the panels, okay, I think the panels are good. Oh no, I think I feel a little bit fluffy. So let's, get new panels and, put them over there. And, that's what we want to do. So that's how they used to do it. And, because the staff comes in from the plane, thinks that, oh, this panel is, not good today. And the other guy says, no, I think it can hold up. I don't think there is any problem, because there's no, so there's no like a IoT sensor for this, right? So they cannot measure that. So that's when we started implementing for, and the airplane can get stranded and people are waiting for 3 hours. They don't know when the plane is going to take off. They just, so there's a mechanical problem. Nobody knows, is the problem with the engine, or is the problem with a panel, or a door panel, or ceiling panel, or whatever it is. They gotta take attention, and then they get the plane going. So now implementing AI with IoT machine learning. So basically implementing the sensors in the IoT. There is a fractal geometry. There's a specific branch of the mathematics for fractal geometry. The fractal geometry is to deal with the surface of any metals. What it does is it basically understands the acoustic emission coming from the surface of that, and it measures the hollowness of the structural integrity of the entire panel. So it transmits the data if there is some acoustic emission, because there's a standard acoustic emission that is defined for a structural integrity of the panel at a certain parameter. And if there is more acoustic emission, then it's deteriorating. So we don't have to get somebody to run through the get the passengers stranded in the airport and all that. So you can just decide just by, the eyewitnesses just tell, okay, you got to get a panel and just put a panel. That's it. So this is a project, implemented for a customer in the aerospace industry.
Yeah, so thank you so much. And moving towards one more important milestone I came across in your career profile, which were you were CEO of Deep Singularity LLC. Would you like to share more about that experience?
So back in the day, I was working for a different company, and then there was a transition period for me to join another company. So that's when I started this company. Mainly, I wanted it to be more like, there is even a press that is attached to it. There's a separate company called High Performance Institute of Technology. So that is actually a press arm of Deep Singularity LLC. So that is for publishing all the books. If you see the book that you were talking about earlier, the big data appliances for it actually came from the press publication of High Performance Institute of Technology. So that's where. So basically, the objective of this company is to promote and bring awareness of machine learning and bring awareness of AI, and also encourage all the youth generation so that they can participate, they can contribute all of their work, and if they want to publish their books, they want to publish their articles, they can publish through Deep Singularity LLC. So that is the purpose of the mission and objective of Deep Singularity LLC, to bring awareness of machine learning and bring it for all the people so that they can start working on it and start having different implementation plans. So that's why I keep tweeting a lot of stuff on machine learning. So I want people to understand it, and some people who are interested can start working towards their goals.
Yeah, thank you so much. And our next section is more about tips and advice to the aspirants. So any tips and advice to the people who are planning to get into this AI and machine learning space and trying to grow in this field?
So it's a very good question that you asked. So primarily what I would say is that the fundamentals of machine learning operate on mathematics. So if somebody wants to implement a machine learning algorithm, the prerequisite is that they need to have the machine learning algorithm. So the audience need to have at least 35% of mathematics background for them to understand how to implement these algorithms. So, for example, I'll give an example. Like, if you're taking a look at back propagation, or you're taking a look at forward propagation, it completely works on the calculus and derivatives and differentiating, the update of the weights on the neural networks and how we can correct the errors. And just like the brain has something called plasticity. So the plasticity, the nature of the brain. If somebody, make a large calculation and they make an error, obviously sometimes the brain neural networks make the error. So they go back and correct the errors through the plasticity. So this is in the neuroscience. The same thing has been implemented in the AI called back propagation. So when a neural network computes and makes an error, it just goes back to the same concept of plasticity, and it just goes and fixes the problem. That is again pure math. So, for example, I would like to refer, Gregory's Taylor series. So Gregory was a mathematician back in the day in 1668, and he has defined this infinite sums of terms with a function defined. For example, I'd say the function a, f of a, is something where we want to calculate infinite sums. And again, it's it's infinitely differentiable. So you calculate the first derivative plus you calculate the second derivative, third derivative, and so on and so forth. So when you accumulate all of this, and then you can calculate in the function, you can actually declare it in a minimal way, like you say, like a sigma of infinity where n equal to 0. So the n is the factorial for each derivative, and it exponential increase. And then you have, the a is the actual parameter we are calculating this function for to know the differentiation. So, so this is very fundamental to understand these mathematical concepts for the enthusiasts, the youngsters who like to get into the data science field. So it's very important and critical for them to, because it's not like, a lot of programmers get into machine learning, a lot of mathematicians get into machine learning, and a lot of statisticians try to get into the statistics. The statistics aspect is again something where people can, apply, for example, like I don't want to know what is the law of probability while I'm running episodic iterations of reinforcement learning. So they can apply the statistics, but it's important, like especially the concepts of back propagation or forward propagation. They do not work on statistics. They work on calculus and math. It's very important to have that kind of background and understanding either academic or they can take up some courses in calculus so that they can understand how to implement this machine learning model with mathematics, because it's not always statistics that determine the outcome of a predictable outcome. I mean, if I'm gonna flip a coin, whether it's going to be a head or tail, that's statistics. So I know I have a probability of that coming as a head, or I know the probability of that coming as a tail. But that doesn't tell me, how do I, measure the projectile of this coin going into the air, which is math. So I think it's very important. A lot of people think statistics is sufficient to get into machine learning, and being a statistician is sufficient. But again, it depends if the person is purely statistician. But probably would never need math at all, because there's nothing to program and there's nothing to run on the neural network. So there's literally, there is no necessity of math. So it all depends what the machine learning engineer wants to be. Be a machine learning engineer or deep learning engineer, definitely they need to have some math background to implement all of these algorithms. So there is more theoretic explanation of how the statistics work, where we can just implement them in our actual programs.
Yeah, this was very insightful actually, and I hope that all the aspirants out there can find it useful as well when they are trying to get into this field. Moving towards the end of the show, which is moreover about the leadership. So our last segment is like one question around leadership. So you are truly leading your passion. So what is your leadership style, and any specific leader that you always follow or admire, and why?
So basically, what I would like to tell is like the approach for leadership is actually is not trying to you don't tell people you need to follow. So it's something where the people have a passion to follow a leader. Because they understand why this person needs to be followed. It's depending on their passion, their understanding, and interest. So you don't force the people into your journey, asking them to follow you as a leader. So you just the people just find the interest in something they get inspired with is what the leadership is all about. So you inspire the people in a way that people find something where they definitely want to follow the leader, because they think this leader has something special. This leader has something innovative to offer, and this leader has something. Somebody you need your inspiration from. So that whether the field you're working on machine learning or deep learning or math or stuff, it doesn't matter. So so we just invite the people into the journey of leadership. You don't force people into the journey, because that's not leadership. So
yeah, that's great actually. Great to hear that. So thank you so much for sharing and being my guest on the SoLeadSaturday show. It was completely privileged, and it was great listening to you, as I am also like not like an expert in this field. I'm also learning. So it was very knowledgeable and insightful, and hope audience you will also enjoy this episode. And as I always say, until we meet, happy leading. Let's lead together. Stay safe. Bye for now.
thank you very much. I appreciate the opportunity for being a part of your podcast. Thank you very much.
Thank you so much.